Imagine empty space with just one object in it, an asteroid. This is the whole universe, a vastness of space-time and one craggy old asteroid. Is it moving, or is it stationary? Relative to what? Is it toppling end over end? How could we know? If it seems obvious to you that we could tell, consider that our whole universe might be moving relative to some multiverse. Our universe might be moving in one direction, or growing, or shrinking, or spinning around. When we stand on the surface of the earth and observe the sky, we notice the movement of celestial bodies. The sun passes over from east to west. The moon does the same thing, east to west. The stars and planets do too. All of these objects can be seen to migrate in that same direction night after night. We all know after Galileo that the Earth is spinning as it rotates around the sun, the moon is orbiting around the Earth, and so on. The movements we can see with our own eyes are relative movements. We see that the stars and planets are moving with respect to us, but it is not obvious that the Earth is moving too, with respect to them. Thus, if we return to space with our single asteroid object in it, and nothing else, we can notice that there is no point of reference anywhere with which to compare the asteroid. There is, of course, no up or down, nor here nor there. But suppose we add a second object. A second craggy old rock not far from the first. Suppose one of them is in motion toward the other. Which is it? How big are the rocks? Are they very large or very small? If they are about the same size, we can only know that. If one is larger and the other smaller, then that is all we can say. All measurements are relative measurements. One thing is measured in terms of another. A yard is 3 feet. A kilometer is 1,000 meters. A pound is 16 ounces. A gram 1,000 milligrams. Whenever we take a measurement, we are comparing our object to some standard ruler. Thereby we attain the magnitude or expanse or duration of whatever phenomenon we wish to document, but always as a relative measure. Imagine trying to say how tall something is without referring to the height of anything else. You can't compare it to the height of a tree, or a house, or a dog. You can't compare it to a meter, or a yard, or a centimeter. The point is that there is no fundamental heightness that can be given. Everything is relative to something else. Is our universe expanding, or is everything inside of it shrinking? There is no way of distinguishing, as far as I can tell, and indeed no need to distinguish, since it amounts to the same fundamental thing. When it comes to fundamental ground-level reality, there seems to be nothing that can be said. Even the laws of our universe are relations between things in our universe. The laws apply to interactions between things. They are internally consistent. That is, they always apply to similar interactions within our universe. But fundamentally, what the hell is going on? I bring up these points about physical reality as a ground from which to move into the realm of consciousness and its phenomena. I have observed that consciousness is a unified composition of meaningful contents. By unified, I mean that the contents all exist from a single point of view. By composition, I simply mean that there are many contents at any given time. By meaningful, I mean that each content is specified. It is something in particular. It feels, or looks, or otherwise seems a certain way. In other words, each content in consciousness is semantic. But notice that each content, each quale, can be described only by reference to other qualia. At bottom, at the foundation, a content is exactly what it is and cannot be further described, only compared. I think it was Nagel who defined consciousness as it being like something to be. What a strange turn of phrase, like something. Like what? Even in this definition, which we all understand, it struggles to make a comparison. I have been reading Marvin Minsky, and I came across some confluent ideas, some ideas that I have put out there in prior discussions that rhyme quite nicely with his ideas. Marvin Minsky wrote on the topics of philosophy and cognitive science, but he was a computer scientist. He co-founded the Artificial Intelligence Laboratory at MIT. The book I've been reading is called The Society of Mind, and I expect I'll be bringing it up in future episodes as well. Today it is a chapter titled The Shape of Space that I'll be taking from. Minsky begins this essay, quote, "The brain is imprisoned inside the skull, a silent, dark, and motionless place. How can it learn what it's like outside? The surface of the brain itself has not the slightest sense of touch. It has no skin with which to feel. It is only connected to the skin. Nor can a brain see, for it has no eyes. It only is connected to eyes. The only paths from the world to the brain are bundles of nerves like those that come in from the eyes, ears, and skin. How do the signals that come through those nerves give rise to our sense of being in the outside world? The answer is that this sense is a complicated illusion. We never actually make any direct contact with the outside world. Instead, we work with models of the world that we build inside our brains." Unquote. In different words, I have very much made the same point throughout this podcast, and I have explained to you on previous occasions that the sensory cortex is laid out in a topographical manner, which corresponds to the array of receptors in the retina, or the skin, for example. It is the receptors on the skin that Minsky continues with here. Quote, "The surface of the skin contains countless little touch-sensing agents, and the retina of the eye includes 1,000,000 tiny light detectors. Scientists know a good deal about how these sensors send signals to the brain, but we know much less about how those signals lead to sensations of touch and of sight. Try this little experiment. Touch your ear. What did it feel like? It seems impossible to answer that because there's scarcely anything to say. Now try a different experiment. Touch your ear twice, in 2 different places, and also touch your nose. Which 2 touches feel most similar? That question seems much easier to answer. One might say that the 2 ear touches feel more similar. Evidently, there is scarcely anything that one can say about a single sensation by itself, but we can often say much more when we can make comparison. Consider the analogy of how mathematics treats a perfect point. We shouldn't speak about its shape. It simply doesn't have a shape. But since we're used to things as having shapes, we can't help thinking of points as round little, very tiny little dots. Similarly, we're not supposed to talk about the size of a point, since mathematical points by definition have no size. Still, we can scarcely help but think in any case they're very small. In fact, there is nothing to be said about a single point except how it relates to other points. This is not because such things are too complicated to explain, but because they are too simple to explain. One cannot even speak about where a point is by itself, since where has meaning only in relation to other points in space. But once we know some pair of points, we can relate these to the lines that connect them, and then we can define new, different points where various pairs of lines may intersect. Repeating this can generate entire worlds of geometry. Once we understand the terrifying fact that points are nothing by themselves but exist only in relation to other points, then we can ask, as Einstein did, whether time and space are anything more than vast societies of nearnesses. In the same way, there is little that one could say about any single touch, or about what any single sense-detecting agent does. However, there is much more to be said about the relations between 2 or more skin touches, because the closer together 2 skin spots are, the more frequently they'll both be touched at the same time." Unquote. Isn't that great? I've really been enjoying reading Marvin Minsky. There's a lot of gold in this essay I just read to you, but I'll focus on a couple of my favorite ideas. These reflect observations about relativity. A single point, just like our single asteroid in an empty universe, is very difficult to conceptualize. Where is it located? Is it moving? Like all other quantitative facts, these require something against which to determine them. Magic seems to emerge once we have 2 points, or indeed 2 asteroids. They have location relative to one another. They can be moving with respect to one another. In fact, by considering the different movements and to which positions relative to one another they move, we can discover 3 dimensions of space. To say which of those is the x, y, or z axis is entirely arbitrary, like any system of measurement, but we can do it in a manner that is reliable once we have made our arbitrary choice. Let's call our asteroids A1 and A2. Let's use A1 as our standard. Using surface features on A1, a little nub sticking out here or a crater there, we can determine what we will call up and down, left and right, forward and back. Then we can observe the motions and positions of A2 relative to those markers on A1. Thus A2 might be drifting up at some angle or moving forward, and the fact that it is moving establishes the dimension of time too. Let's take these observations into the space of subjectivity. A sensation and another sensation can be compared. The more sensations we have, corresponding to an orderly topography of networked cortical neurons, the more we can learn about our environment. Imagine being trapped in a dark room with no sound. You are free to move about the room. You feel with your hands and discover a wall which you follow to a corner. You stand up tall and find a ceiling. You find various objects or furnishings in the room with your fingers and hands as you explore. You discover their sizes and weights and shapes. Some are small. They fit in one hand. Others have much larger expanses. All of these things are happening in your brain, using only the signals transmitted from your skin receptors, just trains of action potentials, and nothing else. Language is syntactical. We have not discovered the name for anything. The name has been given to it as an arbitrary label. Qualia are not like this. We discover qualia. The sensation that occurs when the tip of your finger brushes against some object in the world, that sensation is semantic. It has meaning. This is why all of the languages have their own words for things. But the things they have words for are generally shared by all languages. The things are real, at least as far as human beings are concerned, but the words are just labels for those things. What about the sensations? The sensations are not things outside the brain, situated in the world. The sensation when you tap your finger on a piece of wood is that which arises given the receptors stimulated in that exact way. In principle, you could stimulate the finger's receptors with some kind of probe in precisely the same manner and elicit precisely the same experience. In fact, no finger need be stimulated at all. The somatosensory cortex could, in principle, be probed in just the right way to produce that same sensation. This means that the word is to the thing just as the sensation is to the thing. Both are constructs with respect to the thing in the world, but they are constructs of very different kinds. The word is an arbitrary label. The sensation is an evolved response. It isn't arbitrary. It has value from the point of view of the conscious being that senses it. If the piece of wood is on fire, it will trigger a different set of receptors and therefore some different action potentials in addition to the others, and the resulting sensation will be unpleasant. How can action potentials produce different sensations with different values? There, as it were, is the rub. You cannot sense the way an object feels, because objects do not feel like anything. They have physical properties, but feeling like something is not one of them. It is useful for complexly behaving organisms, such as us, to feel something when we come into contact with an object. Any physical property that the surface of that object has might inform us of something valuable to us. Is it smooth or rough? How big is it? Does it look shiny or orange or dull or transparent? Does it taste salty or sweet or bitter? Does it smell like something? In the conceptual domain, what does it remind us of? How might we use it? Any receptor systems that we have can be brought to bear on the object in question. Any receptors we don't have, say for radioactivity or propensity to reflect ultraviolet light, will leave those properties unknown to us. Incidentally, I wouldn't advise using this set of experiments at the supermarket. It's probably better to just read the label. Notice that the sensations we have are not arbitrary with respect to our needs. They are arbitrary with respect to the things out there in the world, but quite fit to our organismal needs. We find bitterness unpleasant. If the object is sharp or hot or freezing cold, it causes us surprise and pain. These are not features of the object itself, as they are. They are evolved values. To us, this chemical residue is bad, so we taste such alkaloids as bitter. To us, this temperature is dangerous, so we feel it is burning hot. But remember that we could probe the correct neurons in the brain to produce these same sensations. Those neurons would communicate with other neurons with which they are networked to elicit the very same response. With regard to subjectivity, then, we need examine the outside world and its objects no further. All of the interesting action is happening in the thalamocortical system of the brain. Those networks have been honed over countless generations to give us the sensations that produce fitness-enhancing behaviors. My project, as you know, is to discover the physical explanation of consciousness. More specifically, I wish to comprehend the identity of subjectivity with some physical system. Having become exposed to leading neuroscientific theories in the background which enables me to read and understand the primary experimental literature, I developed the temporally integrated causality landscape and published it last year. Relativity is of central importance to the theory and its implications. I observe that the contents of consciousness have meaning, and I propose that meaning is the relationship between things. The qualia that we experience are meanings. They are qualitative expressions of relation. For example, a color is what it is in relation to other colors and other sensations. Donald Hoffman shows a color figure that he designed to demonstrate an important visual illusion with regard to color constancy in his book, The Case Against Reality. It shows a three-dimensional Stetson hat checkered with colored squares. The figure is lit from above and left so that the squares in direct light are brighter in appearance than those outside of direct light. Hoffman describes it here, quote, "Joseph's hat sports many colors, which we decode as surfaces and lights. We interpret the brown rectangle on the left side of the hat as a brown surface in direct light, and the yellow rectangle on the front of the hat as a yellow surface in shadow. You can also see these two rectangles as the same color. If you cover all of the hat except these rectangles, then they look the same brown. In fact, when creating this image, I used the dropper and paint bucket tools of Photoshop to make the pixels in the two rectangles identical. You can decode this image in two conflicting ways, one in which the rectangles are the same brown and one in which they have different colors. Neither portrays objective reality. Both are simply messages about fitness. You decode disparate messages in different contexts." Unquote. This figure is quite compelling. It really does appear that the squares in question are very different colors. The colors in the shaded area of the hat have a certain relative shade that is different from the colors in the lighted area of the hat. The surrounding squares provide the context for what we see, so our perception is driven by relationships among concurrent sensations. We don't see things as they are, but how they relate. Likewise, a melody can be played on a piano or a guitar in any octave you like. The exact frequency of the sound waves as objective occurrences does not matter for the purpose of the melody. What matters is the ratio among the frequencies in the melody. According to the temporally integrated causality landscape, conscious content exists because subsystems within a single integrated system are distinguishable from noise. They have particular features that exist from the point of view of the system. They have meaning, which is specified by their relationships to one another. Relationships are like ratios. They can be expressed in terms of geometry, and ultimately I think subjectivity is a matter of sensing geometric relationships. In mathematics, I favor thinking in terms of reduced fractions rather than decimals or percentages or whatever. It seems to me that these fractions express the raw relationship between things. If you have 4 stones and 3 of them are red, then 3/4 are red. It is also true that 0.75 of the stones are red, but that is a translation in values in terms of tens. It might be useful for doing math, but it converts the data into a different scale. The problem frequently arises, though, that this makes real things seem exceedingly complicated and vexing. Consider, for example, if we have 3 stones and 2 of them are red. No problem, right? 2/3 are red. But in decimal form, that is 0.6666 forever and ever. And this makes a simple, commonplace relationship extremely difficult to comprehend. The world never gives us 0.6666 red stones. It took our mathematical conventions to come up with such a thing. How about the value of pi? It seems a vexing quantity, 3.1415, on and on. But in fact, it is a simple ratio, that between a circle and its diameter. The decimal value of pi is misleadingly intimidating. It's a useful concept, but ultimately a simple matter of geometric relations. I think consciousness is a composition of relations. We aren't witnessing the points in space. We aren't seeing the lines that connect points, and we aren't seeing the Euclidean figures, the triangles and circles and polygons. It's as if we are privy only to the relations between figures and their elements. A color sensation cannot be an objective point or line in space. If it were, then the context wouldn't matter. The color would be apprehended always the same because objectively it always is the same. If Minsky's Photoshop software was sentient, it would know that the color of the rectangle in direct light is the very same as the other rectangle in shade. But the program would not know that there was an area of direct light or shade, because that is an illusion for our benefit. It would not even know that the figure showed a hat. We see the colored rectangles as different depending on the surrounding colors and the perceived lighting. We see a hat. That alone is remarkable because in no objective sense is there a hat present. The hat is an emergent property of the relations among the points and lines of the figure. Just as Minsky observes that 2 nearby touches of the ear are more similar to one another than to a touch of the nose, I notice that 2 visual sensations of colors are more similar to one another than to the smell of rosemary, or to a musical note. The thalamocortical system must be arranged in such a way that these different modalities express very distinct geometries. The mind must be that multidimensional space within which these geometries occur. The points and lines are composed of action potentials within a vast interconnected system. We do not see or feel or otherwise know those action potentials. Rather, we see and feel and know directly the relationships among them, and from those relationships we reverse engineer the physical structure of the world.